Guys, so today we're gonna explore the chemistry behind egg cooking. So eggs are super rich in protein, especially the egg whites. And this protein is what causes the egg to become hard once it's cooked or boiled. Ovalbumin is the major protein found in the egg whites, and it makes up more than half of the total protein in the egg. The other proteins that could also be found in an egg would be ovotransferrin, ovomucoid, ovomucin, and lysozyme. So protein is a chain of amino acids, and these amino acid strands fold back on themselves. And the way these strands fold back on themselves will determine the protein's chemical and biological properties. And these proteins are held in place by non-covalent weak bonds on different parts of the amino acid strand. And when you break these strands, say by boiling the egg, you are denaturing the protein. So what we're gonna do first is boil this egg.
So the process is super simple. All you need is a pot, some water, and an egg. And you allow the water to come to a boil and let the egg sit in there for about 6 to 8 minutes. And by then, the liquid egg should have fully solidified.
So when you heat an egg, the proteins absorb that thermal energy and they literally shake apart the bonds between the parts of the amino acid strands. And this causes the proteins to unfold. And as the temperature gradually increases, the proteins are able to gain enough energy so that they can form new, stronger covalent bonds with other protein molecules. So as we're boiling the egg, the heat first unfolds the proteins, and then it allows the proteins to link to other proteins. As the proteins form these new strong bonds, the water that surrounded each protein molecule when the egg was liquid is forced out. That's why the egg turns hard. Using heat is the best way to cook an egg because it affects all the proteins in the egg. But you can also break these same weak bonds between the protein molecules using chemicals. A study has shown that if you add alcohol into an egg white, the alcohol will break the weak hydrogen bonds found in the protein.
So this was right after adding the alcohol, and we noticed that there wasn't really a change in consistency.
The study also stated that adding vinegar to an egg white allows the acid to break the ionic bonds. So here we added apple cider vinegar. Though not noticeable, the consistency was a bit thicker. So if we were to add both the alcohol and the vinegar, theoretically we would be able to break both types of bonds. Though not noticeable here, these chemicals are considered quite effective in denaturing the protein of the egg white. So I realized that the reason why we didn't see much of a reaction is because I didn't wait long enough for the reaction to actually occur. So after referring back to the article, I learned that depending on the percentage of the alcohol used, it will determine the reaction rate. And it usually takes at least an hour for the reaction to occur. And the egg that was chemically cooked is considered to be edible, considering that you use alcohol that is safe to drink, but it does have a high concentration of alcohol. So it's really up to you if you would want to eat it like that. And it's important to note that this chemical reaction only works with the egg whites and not the egg yolk. Because even though the egg yolk is also rich in protein, like the egg white, it does also contain a lot of fats and other properties that will make it more difficult for it to become hard. But the way this would have worked if I had let the reaction finish would be after a few minutes of adding the alcohol to the egg white, the solution would have gone from a translucent to a cloudy mixture. The alcohol and the acid would participate in a chemical reaction that denatures or changes the conformation of the protein molecules, and they would be able to form new linkages with each other. And as the alcohol would diffuse into the egg white, the reaction would proceed, and then the egg white would turn solid. Now to get back to our boiled egg, as you can see, it is done cooking and it has went from a liquid state to solid. Now this is our egg cut in half. And it's hard to tell here, but usually when boiled eggs are cut in half, they have a sort of green layer around the yolk.
This green layer forms because the egg was cooked in high heat. So it is important to cook the egg in moderate heat in order to prevent this reaction between the yolk and the egg white. This green film is known to be iron sulfide, which is caused by the iron in the yolk reacting with the hydrogen sulfide in the white. This prolonged excess heat speeds up this reaction. So in order to prevent the yolk from turning into a greenish gray color, you must submerge the boiled egg into cold water in order to stop the iron and the sulfur from reacting. Lastly, there is another way that we can also break these same bonds that we were talking about before. We are able to create a similar reaction by whisking egg white. By exerting mechanical energy through the whisking process, you're able to cause the protein bonds to break and then subsequently reconnect. And once these new stronger bonds are formed, the egg stays in that state, thus allowing the proteins to form a network of strong permanent crosslinks. And these cooked, chemically altered, or well-beaten eggs will never go back to their original liquid state.